You're pretty close.
Say hi.
Hey, how you doing?
Good.
Good seeing you. Welcome to the Special Committee on Bay Delta. This is now an opportunity for the public to address the committee on matters within the committee's jurisdiction. Do we have any cards or anyone wish to speak to us? Okay, thank you. Next item is approval of the minutes for the meeting of the Special Committee on Bay Delta for both October 25th and November 22nd. Can I have a motion?
Second.
Moved and seconded. Any discussion? Hearing none, all please vote. Item passes unanimously. Next item is committee item, update on California water fix. Randall Newdell.
Good morning, Mr. Chairman, members of the committee. We want to give an update mainly on the process over the last 10 years or so on the Cal water fix. And we started this process, I think Roger and I, back in 2006. That was when the State Resources Agency, Karen Scarborough, was the lead on developing or had a steering committee made of urban, agricultural, and environmental, a non-governmental organization interests out there. You'll see on the slide kind of an area of 2007, 2011, doesn't have any milestones. That's the time where a lot of the staff work was done. A lot of the modeling from an environmental modeling, water supply, water quality, air quality, all that type of modeling analysis was done during that blank period in the slide. Then we started getting into some milestones. Remember, there was actually 3 drafts of the environmental document that came out in 2012 or 2011 was that administrative draft that the state agencies put out. And then in 2013, the first draft of the public EIR and a second draft of another public EIR. So now what you're seeing over these next 3 years is really, or since 2015, 2016, and this year, is really a accumulation of all those milestones coming to fruition. In 2016, the final environmental document was put out. The agencies, the state agencies, federal agencies, completed a draft biological assessment. That's in front of the fishery resource agencies, and they're developing the biological opinion on that. We expect in 2017, this year, that they'll final that biological opinion and the 2081 permit. That will have the Corps will hopefully have a permit on their 404 process, and the agencies, state and federal agencies, will have a record, a decision. And the goal, obviously, is to bring these documents to your board with the cost-sharing agreement for discussion. Mr. Chairman, that's really all I have today. Just wanted to give an update on the process. Be happy to answer any questions.
Keith Munger.
Thank you, Mr. Chairman. Randall, these various milestones in 17 and 18, we're all, at least I am, expecting that somebody's going to sue the state over these plans. Which of these milestones are potentially the subject of litigation?
Does our legal office want to take that?
Potentially all of them, actually. I mean, the truth of the matter is, anytime you have issuance of a permit, once you get to the final decision, they can challenge any aspect of that approval process.
And so, I know it's difficult to speculate, but do we have any kind of feel for how long that type of a litigation might take to wend its way through the courts?
I couldn't say on that. I couldn't speculate. I don't know.
It's not a short thing, is it?
No, it's not going to be short. I mean, the shortest one of the bunch would probably be the NEPA lawsuits. Those tend to move more quickly because it's based on generally the admin record, and it's the admin record is usually a little bit more manageable. But in this case, it's a very large project, so I don't even know if that would be true. But it's not going to be a short process.
So is it fair to speculate that the start, assuming we can win all these lawsuits, the start of the project is going to get delayed somewhat?
Yeah, I don't
by
know.
whatever it takes to finish the lawsuits, right?
You don't actually know that. You don't necessarily finish lawsuits before you start construction. There's many examples of major construction, Hyperion Treatment Plant, the Century Freeway. All these projects were built while litigation was going on one forum and construction
That's
taking
good to
place
know.
on a parallel track.
Thank you.
Director Pascal?
Can staff talk a little bit more about the final documents? Maybe give us a little bit more color or detail about what's in them. Maybe what's different than what you expected, or is it what you expected? Are there any high points that you would want us to know about?
I mean, I could, Director Pascal, I could take a little bit of shot at that. We haven't actually seen the draft permits yet.
I'm sorry, I meant the documents you got at the end of the year.
Yeah, so
Sorry about that.
the fishery permits, the endangered species permits, are based on looking at what's called a biological assessment, which went over. And we have briefed the committee on what was included in that. And normally, we hope that this is the case, the permits reflect what was in the analysis asking for the permits. So I don't think we'll see any surprises there. We haven't really seen a full copy of those draft permits yet. We've seen pieces that have gone out for independent science review. That has to be taken into account in the final, so there could be some changes there. And the other thing that's going on is obviously timing-wise, we have a change in federal administrations coming in, so they're going to be finished under the watch of the new administration, of which we don't have any confirmed folks in place yet. So I think it's fair to say we really need to keep an eye on this and see what we can learn by reading the various pieces that we do see, because we just don't know yet. That's kind of the next step here.
Do you have any, I know you said you don't know, but do you have a guesstimate? Are you thinking mid-year or end of the year?
The schedule that the agencies gave us, setting the transition aside, was April, 1st of April. So, if you take, I'm saying at least a couple of months probably to have new folks take a look at that. So it's in that kind of a time frame. Could be longer.
Okay.
Maybe not. Maybe they'll just say, go ahead.
And your team also mentioned in the presentation that the cost sharing agreements would follow. So are you thinking of bringing that to the board around April? Or maybe later?
We've always wanted to bring the cost allocation at the same time that we have the permits, and it looks like it's on track to do that. So I think that's coming along, particularly on the state water project side. The federal side seems it's lagging just a little bit, but that's our plan, is to bring it in its entirety, because you got to see the whole package.
Any other questions of Randall? Thank you, Randall. Next item is project implementation considerations for California Water Fix. John Bernowski.
Yep.
Welcome.
Yeah, thank you, Mr. Chairman and members of the committee. I will be presenting really a kind of a two-part presentation today, but this is the first of two presentations, January and February, which will give a little bit deeper dive on some of the implementation aspects of the California Water Fix. So today I'll be covering initially an overview of the California Water Fix facilities, and then talking about our review of other mega tunnel projects that have been completed or in the latter stages of completion, comparators to the California Water Fix tunnels. In February, we'll be covering risk management on the program, not only construction risk management, but also design risk management, and then also be reviewing the cost estimates that have been prepared for the California water fix. We've had 2 separate cost estimates prepared. They're within 7% of each other, but you'll get a deeper dive on that in February. So California water fix overall program stretches as the crow flies about 38 miles from the intakes on the Sacramento River down to Clifton Court. Along the way, we have 3 river intakes, each at 3,000 CFS. The water from those intakes is collected into what we refer to as the north tunnels. That water then flows to the intermediate forebay, where the water is commingled together. The hydraulic grade for the twin tunnels is set at that point, and the water flows then through the main tunnels down to the Clifton Court pumping plant, where the water is lifted into Clifton Court and then can be distributed to either the Jones or the Banks pumping plant south of Clifton Court. On the tunneling portions of the program, the north tunnels comprise of approximately 9 miles of tunnels. Fairly large tunnels up here because we have a completely gravity-fed system now with the revisions that we made during the EIR-EIS process. So those tunnels up there range from 28 feet in diameter to 40 feet in diameter. They convey the water from the intakes to the intermediate forebay. At that point, the water is split into the twin tunnels, 40-foot inside diameter twin tunnels, which carry the water 30 miles to the south to the Clifton Court pumping facilities. Total of 69 miles of tunnel with this program. The main tunnels will focus on those. They're going to be designed with a 100-year lifespan. Primarily what that means is that the tunnel segment design will be very robust, along with the gasketed liner. This will be our primary liner for the system. There will be no steel liner inside here, so we'll be relying entirely on the segmental liner design and the gaskets to prevent either infiltration into the tunnels or exfiltration leakage out of the tunnels during operation. We've conducted a number of studies based on a revised hydraulic profile. We're very confident that these tunnels will operate very well with minimal leakage either in or out of the tunnels. The tunnels will be about 150 feet below grade, and the importance of that is that water pressure at the bottom of the tunnels will be about 65 psi, and because we're not in rock tunnels, we're in what is considered soft ground, fully saturated ground. Once you open up that ground with the tunnel boring machine, if you do not have what we call a pressurized face tunnel boring machine, that ground will tend to run into the machine in an uncontrolled manner. So the type of tunneling technology that we're looking at will be pressurized faced, either earth pressure balance machine or a slurry machine will be employed by the tunnel contractors. Excavated diameter is 45 feet. Tunnel segments are about a little bit more than 2 feet thick. The inside diameter of the twin tunnels 40 feet in diameter. Many people ask us the question about, these are very large tunnels. How do they fit in with the state-of-the-art of tunneling technologies? We feel that we are situated squarely in the middle of large tunnel boring machines. We don't feel that we're at the bleeding edge of technologies. We're letting others set the pace there. 3 tunnels I want to point out that are the largest in the world. The Sparvo tunnel in Italy, a road transportation tunnel, was the largest until that was surpassed by the Seattle tunnel about 5 years ago with that design. Just want to point out at the time that design was about 30% larger than the Sparvo design. So this was a large increase in the size of the design. Many people have heard about the Seattle tunnel. I'll touch on that later in the presentation. But since that time, the Seattle tunnel has even been outstripped by a larger tunnel in Hong Kong, 58 feet in diameter. So as you can see, larger and larger tunnels are being built now. But again, we feel that we are comfortably in the middle of the large tunnel boring machine technology. Some of the program facts: over 700,000 tunnel segments will be used. This translates to about 80,000 segmental rings will be constructed in the program. 23 million cubic yards of material will be excavated from the tunnels. This has all been accounted for in the EIR-EIS. This material will be stockpiled near the tunneling sites on the islands as we move south through the delta. 10 to 12 tunnel boring machines will be in operation at some point simultaneously during the program. And then to point out, almost 200 megawatts of power will need to be brought into each of the launching shafts for these machines. We do have large high voltage transmission lines that go through the delta, but these are to transport power up and down the state. So we are working very closely now with a number of different power providers in the delta to ensure that we can bring in the requisite required amounts of power to run these machines. This is a long lead time item, so some of this work has already been started by DWR in advance. Just to give you an overview of the river intakes, we have 3 of these at 3,000 CFS each, ranging in length, depending on the morphology of the river at the different locations, from 1,250 feet long to over 1,600 feet long. These, the configuration of these intakes mimic two very successful intake projects that are located about 2 hours north of Sacramento, very similar in size, 2,500 to 3,000 CFS. So we've used that same concept of a screened intake along the river levees. The water will be conveyed through box conduits into those earthen sedimentation basins in the background. It's about 1,300 feet from the face of the screens to the back of the sedimentation basins. At that point, you can see an outlet shaft. At that point, the water will drop into the tunnel system and then be carried south to Clifton Court from that location. At the terminus of the tunnels, we are planning to provide 2 large pumping stations, each one at the terminus of a tunnel. So we have 2 of those, 4,500 CFS each. Vertical turbine pumps will lift the water about 15 to 20 feet out of the bottom of the tunnels and deposit that into Clifton Court, where it will then flow by gravity to both the Jones and the Banks pumping facilities. Cost estimates have been prepared. As I mentioned, we have 2 cost estimates that have been prepared in 2014 and 2015. The cost numbers shown here are in 2014 dollars. That's when the first estimate was prepared. Cost estimates are within about 7% of each other. And for this estimate that we're using now going forward, the 14.94, we're using the higher of the 2 cost estimates at this point in time. So you can see from this slide, tunneling costs are projected to be about $6.8 billion. Contingency on the tunnels and the remaining construction is at 36%, about $3.4 billion. And that all totals up with the land acquisition and the labor for PM, CM, and design, $14.94 billion at this point in time. Again, 2014 dollars. We also have developed an organizational chart that will be put into motion once the DCE agreement and all the other documents are put in place and funding is secured for the program. Wanted to give you an overview of the organization chart, which will be led by the program director, and then direct reports to the program director will be things like finance and accounting, legal counsel, and I'd like to point out at the upper right, because just to illustrate how seriously we take risk management on this project, the risk management of the project will be a direct report to the program director. We'll touch on that a little bit later in the presentation. Below the program director is the program manager. That will be an inward-facing position that will be responsible for managing the entire program. Directly below that, position entitled Chief Engineer, and then below that will be the design. This is for design. This org chart that's shown here, the design phase, will be the engineering design manager, who will be basically leading the design effort for all of the activities that to be constructed under this, including the tunnels, which are shown on the left side of this diagram. Schedule for the program. Once the program is authorized to move forward, we're anticipating a 16-year implementation time frame. About 12 to 15 months early on, we'll be staffing that organization chart that I showed. That'll be hiring the in-house staff that will man a number of the key positions, as well as hiring the consultants that will be performing a number of the key work activities. There's about 4 years of land acquisition work that will take place early on in the program. We've learned from other projects that it's really important to make sure that you have all of your property acquired before you begin construction and start awarding construction contracts. And then about 4 years after the commencement of the project, we'll actually begin work on awarding tunnel construction contracts. So tunneling will not start right away. I just want to make sure everybody understands that. And once the contracts are awarded, tunneling will still not start right away, because we anticipate that the contractors will be responsible for sinking those large shafts that will serve as the launching points for the tunneling activity. So again, a 16-year overall implementation schedule. During that construction of the tunnels, it goes for about 11 years. We're anticipating that 10 to 12 tunnel boring machines will be operating simultaneously during periods of that program, especially in those key years 7, 8, and 9. A lot of tunneling activity taking place. Again, 10 to 12 machines working. It's not an unprecedented, it's a large number of tunnel boring machines to be operating simultaneously, but it's not unprecedented. In Mumbai, India, they have up to 17 TBMs working on their metro system simultaneously. In Doha, Qatar, 21 TBMs. And then closer to home in Mexico City, they have up to 8 TBMs working on a sewage collection system there too. So again, we feel that strongly that the management of the tunneling activities is within the state of the industry practice these days. So now what I'd like to do is kind of shift gears and give you a review of some of the other mega tunneling projects in the world. We have kind of a selected list. Many of these are what we call soft ground or mixed ground tunneling experiences that have been completed. We've got the Seattle Tunnel at the end of the list because we get so many questions about that project. We did want to definitely hit on that. And we have one hard rock ground. It's called the Goddard Base Tunnel. You'll see why bring this one into play for discussion also, but we did want to kind of give a review of some of the larger tunnel projects that have taken place throughout the world. So we'll start with the Eurasia Tunnel Project. This is a tunnel that basically crosses underneath the Bosphorus Straits, kind of the divider historically between Europe and Asia. This is a project that won recently the International Tunnel Association Project of the Year in 2015. It's a 45-foot OD. There's a typo in here. It's actually 40-foot inside diameter. So again, very similar to our size tunnel project. It was a design, build, operate, transfer project. So kind of a unique delivery mechanism for this project where the contractor both designed it, built it, operating the tunnel, and then in the future will transfer that tunnel back to the owner. The project was completed ahead of schedule and within budget. Some of the key challenges were you're passing about 300 feet under the Bosphorus Strait, so water pressure at that point was about 165 psi. So quite a bit more than we have encountered with ours. They crossed an earthquake fault, so they had to install a seismic joint inside the tunnel. All of this was installed without a hitch. Tunnel went into operation last year. The Lee Tunnel is part of a multi-tunnel effort, part of the Thames Tideway project in London. It is a CSO project, and by that I mean a combined storm overflow project, a series of tunnels linked together to capture surface runoff before it goes into the Thames River. The tunnels act as a collection and storage system, whereby then as the rains subside, the water can be pumped out into a water treatment plant or wastewater treatment plant and then deposited back into the Thames River as clean water. The project there that has been recently completed is the Lee Tunnel. A complex project, about 24 feet in diameter. This project was done with the design-build approach. It was completed in December 2015, on schedule and slightly under budget. Some of the complexities of this project is it was constructed in urban London, so you had issues with work site availability, contaminated soils that they dealt with, and also offloading the tunnel material that came out of the tunnels. They had offloading issues with that, but again, project was completed successfully. Now we move on to the Port of Miami Tunnel, recently completed. This was another unique delivery method. They used what we call a triple P, where actually the tunnel designer, owner, work out a relationship whereby the designer, builder, and concessionaire of the tunnel are the same entity. So this is a unique opportunity here for, again, design build to be used in a procurement method also. Tunnel is very similar in size to the California water fix tunnels. A very deep tunnel, 120 feet, passing underneath the Port of Miami in transportation tunnel. It was open to traffic in 2014, came in under budget. Some of the main challenges were the ground was very challenging. You were going through very soft limestone material as well as coral. There was a lot of grouting required on this project. There was a lot of investigation by the owner prior to issuing these contract documents as to how to best share the risk on this project because they knew the ground would be very challenging. But the risk transfer, risk sharing worked out very successfully. The grouting operation was a complete success, and so was the tunneling operation. East Side Access, this is a very large project, about $10 billion. It was conceived to enhance the connectivity of the Long Island Railway to Penn Station. The project that we're focusing on is the Queens Board Tunnel at the bottom there. This is about an $800 million project. Very complicated project. This was done with a design, bid, build, delivery approach, but the unique aspect of that is they had two potential bidders for this project. Because the work was so challenging, they ended up negotiating actually the contract with the eventual winner or the successful bidder on this project. Very shallow ground cover. You were crossing underneath active railway lines, and you also had many cobbles and boulders in that ground, so there was a lot of ground freezing used here. Very tricky tunneling, but the tunneling project went through very smoothly and successfully. Blue Plains project, this is part of DC Clean Water's overall CSO program once again. This is a 5-tunnel program. The Blue Plains project is one of those tunnels. It was completed successfully, along with the second tunnel, the Anacostia Tunnel. Some of you may be familiar with that. It's completed in Washington, D.C. Delivery approach was design build here, completed in 2005, ahead of schedule and under budget. Some of the challenges here are a bit unique. This was the first time that this agency had used design build, so there was a lot of institutional resistance to that approach initially. Now they're implementing the rest of the tunneling project with the same approach. Program is going very, very smoothly. Bay Tunnel. Some of you may be familiar with this. It's part of the SF, San Francisco Public Utilities Commission Water Supply Improvement Program. It's a $5 billion program, basically to go throughout the entire SFPUC system, make upgrades to their system for seismic reliability and other reliability issues. This is the second largest project within that program. Calaveras Dam rebuild is the largest at about $800 million. But this was almost a $300 million tunneling project. The reason it's very unique to us and applicable, 5-mile tunnel drive. Our tunnel drives that we're looking at are 8-mile, no intermediate shafts on this, similar to our project. First tunnel underneath the bay, a bored tunnel underneath the bay. Those of you that have been on the BART system, those are what we call immersed tube tunnels. So this was the first time that a tunnel had actually been bored underneath the bay. Very successful project. Again, there were some issues with contaminated ground, but the project finished on time and within budget. Now we'll move on to the city of Portland. They also have a CSO project. Many cities in the U.S. have been having to comply with EPA requirements to clean up discharges into waterways, and the city of Portland is no different. Very large project here, 2 tunnel contracts, one on the east side and one on the west side of the Willamette River. This project was delivered in another unique delivery method. Because of their prior challenging experiences with design bid build, when they committed to taking on these 2 large tunnel projects, they decided to go with what they call a cost reimbursable fixed fee procurement method. Under this approach, the contractor is hired early on with a fixed fee to work directly with the design engineers and the owner to plan out the project, and then they negotiate an actual reimbursement schedule for tunneling the actual tunnel works and building the shafts and the pump stations. Reasons for this, again, prior challenging experiences with design bid build, also very challenging ground, a lot of rocks and cobbles and boulders, and also the need to do a lot of soil modification deep down in the tunnel shaft. So project was completed 8 months ahead of schedule and slightly under budget. Now we'll talk about the Goddard Base Tunnel. This is the longest tunnel in the world. Twin tunnels, each one 35 miles long, about 6,500 feet underneath the Swiss Alps. Very, very massive project. I believe it's a $10 billion project. Hard rock tunnel, so it'd be different than the California water fix. But the reason we're referencing this one is, again, project size, $12.5 billion. It was over budget by about 7%. This was over 17-year construction period. So talking to the folks on this program, they feel it was very successful. Because of the rock conditions, the tunnel boring machines did get stuck several times. Because of squeezing ground conditions, they had to work those out. We're not anticipating we're going to have squeezing ground conditions with our soft ground tunnels. That just doesn't happen with soft ground tunnels. So 95 miles of tunnel altogether, and again, 7% over budget. But the project is completed and was put into operation last year. Finally, we'll touch on the Seattle project. It's called the SR-99 Alaska Way Replacement Project. At the time this project was conceived, it was the largest tunnel boring machine in the world. $2 billion program for the state of Washington to replace the elevated viaduct that goes along the waterfront in Seattle. 53-foot inside diameter, 57 feet outside. Again, largest in the world. Project was procured with design build. They are currently experiencing about a 2-year delay. I'll touch on that in a few minutes. Project had, again, a $2 billion budget, but challenges are primarily with the tunnel boring equipment, some of the site supervision, and also the way that the project was set up and the project specifications. I'll touch on that now. So this is what's been happening with the Seattle tunnel. I guess being a tunnel nerd, I've checked these things on Twitter, as you can tell. As of this morning, they're about 75% complete with the mining. But how did they get there? It was a pretty long, involved story. Mining started in mid to late 2013. They got about 1,000 feet into the job, and basically the machine broke down. Took them a couple of years to figure out what was wrong, how to fix the machine. They eventually mined into a large access pit where they pulled off the cutter head. They replaced the main bearing, put everything back together. They are now mining, making excellent progress. We've met with their new project management team up there, very confident that they will finish mining this tunnel by the middle of this year and begin to finish out all the fit out of the tunnels. So what were some of the reasons behind that? Those problems that they've run into, the best that we've been able to discern. Issues with the tunnel boring machine are probably first and foremost. As I mentioned early in the presentation, this machine, when it was designed, was about 30% larger than any other machine. The tunnel boring machine manufacturer had never made a machine this large. As evidenced by the amount of steel that was put into the machine when they repaired it and replaced the main bearings, about 100 tons of steel was added to the machine. So it would lead one to believe that the machine was under-designed when it started out. Second reason that we understand is better supervision now in the tunnel as the machine's moving forward has allowed them to optimize their production of the tunnel boring machine to achieve these good production rates as you see on the right-hand side there. And then finally, the way the contract was originally set up, design build contract, but the owner put in an upset price, bid price, whereby if a contractor submitted a bid above that upset price, that bid would not be accepted. So the feeling now of the project team in Seattle is that that artificially suppressed the bids. They feel very strongly that in tunnel projects, the work is the work, and it's going to be what the price is when you get multiple bidders on that, and the owner should really stay away from putting upset bid prices in there. So there is a strong feeling that if they were to do another tunnel project, they would not bid it with an upset bid price. So what are some of the lessons that we've learned from this project? I'll just kind of go through those because we have talked with a tremendous number of entities about this, and I think there are a lot of lessons learned that we can apply to the California water fix tunnels. I think first and foremost, the recommendation is to have a proactive risk identification and management program. When I showed the org chart, you can see that we positioned risk management, very high position in the org chart, reporting directly to the program director. Good geotechnical information is key. There is no way for an owner to get out of responsibility for the condition of the ground. So we have to do a very good geotechnical investigation for this program. That has not started yet. That will be some of our early activities. Select a delivery method, a project delivery method that is appropriate for the type of work to be done. I've discussed a number of different methods that have been implemented on a lot of successful tunnel projects. We still need to ascertain what might be the best approach for the California water fix. Build a strong owner's team. It's imperative that you have a knowledgeable owner that's running the program, a knowledgeable owner that's embedded throughout the project team that's guiding the work of consultants. Our organizational chart has been developed to create that exact result. And then finally, resolve right-of-way issues early on. We have planned out a very aggressive right-of-way acquisition program that will be implemented in the very early stages of staffing the office. We anticipate to have all of the access to the key project sites acquired before we begin any construction work. So with that, again, the next steps will be to present to this committee in February on the design and construction risk management process, as well as the cost estimates that have been generated for the program. And with that, I'd like to wrap up my presentation. If there's any questions, I'd be happy to answer those.
Yes, any questions?
Yes.
Director McKinney?
Thank you, Chair. This is a great presentation, and I really appreciate the fact that we had some examples of projects that had some hiccups that we could take lessons from. I'm curious, did we not find any projects that just failed completely?
Personally, I am not aware of any that have just been stopped. And there was talk about in Seattle about just stopping the project 1,000 feet into the ground. They had the resolute desire to move forward, and it did. But I'm personally not aware of that. I know that we had our own issues with the Arrowhead tunnels. We worked through those issues and completed those. So I couldn't suggest any.
No, I'm in the same boat. I mean, even like the big dig in Boston, eventually they just, you got so much money and time and energy, you just go in and finish it and gut it out, even at a, several times over cost overrun. I'm not aware of one where this board actually contemplated backing off at it and just going around their Arrowhead Tunnel project, but it was just too hard. So eventually we went back in and finished the job, and that's usually what happens.
Okay, thank you. Director Murray?
Thank you, Mr. Chair. Hey, good morning, John.
Hey, good to
How
see
you doing? Just a couple of questions. On the material side, I noticed 700,000 segments
Yes.
on this. Are we anticipating purchasing those segments from the same vendor, or will there be different vendors?
We're evaluating that now. That's one of our questions. There's really two parts to it. Should the owner procure the segments and the tunnel boring machines ahead of time? Should we let the contractors take care of that? If I was to offer an opinion, I would anticipate we'd have the contractors purchase both of those pieces of equipment and material, and probably come from multiple sources.
And be responsible for quality control, quality assurance on those?
Yes, with our oversight on that. But that, again, that's my opinion at this point. We haven't locked in on anything there.
Same question on the TBMs, because we're using multiple TBMs. Same manufacturer or different?
There are multiple manufacturers in the world. I think that this is something that we want to get into immediately as we staff up the office, is to get some expertise around that question, whether we put everything together with one machine manufacturer or spread the work around. Again, this may come back to the question of whether we as the owner procure those machines or we allow the contractors to do that. But I would anticipate there would probably be a pre-qualification of the TBM suppliers ahead of time, so that there would be a short list that they could be selecting from.
Okay, and last question, land acquisition. More than understandably, we're not going to start that until a certain point.
Right.
How have we calculated into the various scenarios? Sometimes you get into a situation that, who you may buy from first, there's a price for their land. Then as you move through the project and people feel that their piece of land is ever more valuable to the project, and therefore the price may start going up. So how are we calculating for that in terms of what the land acquisition may ultimately cost us?
For our estimates right now, we've used like an average market value. We haven't taken into account that type of escalation, but we could bring back a presentation to this committee about the property acquisition approach, if that would be desired.
Okay, great. Thank you, John.
Look to the left sometimes. Is Lewinger going? Are you going?
I said Director Lewinger. I didn't see her hand. I'll call you next.
Thank you, Mr. Chairman. Could we go back to slide 10 on the cost estimate?
Sure.
I'd like to understand the footnote. So you repeated, you said this is in 2014 dollars.
That's right.
Does that mean that you're estimating 16 years of construction based on 2014 dollars, or are you assuming the project gets built in 2014?
It would be a snapshot of that cost estimate in 2014.
Okay, so two things. It's a 16-year project. So right off the bat, you've assumed it's going to get built in 1 year in this cost estimate. That's what you just said.
Yes, that's correct. That's the way these estimates are put together.
So first thing we need to do is, I've typically heard of escalating to the midpoint of construction. So we're already 8 years into the future, and we're 3 years beyond your date. So we're 11 years beyond your cost estimate, sitting here today with no legal, as I raised earlier, legal delays in the process. When you come back, I'd like to see a new cost estimate to take into account a 16-year construction schedule, and that construction starting at the earliest in 2018.
Yes, we can address that issue next month when we talk specifically about the cost estimate.
Thank you.
Sure.
Director Pascal?
That was one of the concerns that I had as well. I'm wondering if, I'm sure you are, but it would be nice to see some updated numbers, both for 2017, but I agree as you go through and do the calculations for the life of the project, so we know if it's going to be close to the, the 15 billion. I had a question. As you looked at other projects, and the examples were really helpful. It's a great presentation. Thank you for doing the type of research that you did. Did you look at smaller projects in the area, maybe by other water agencies or utility companies who did boring and underground tunneling near the Delta? Maybe East Bay Mud or some of the utility companies up there?
Well, I would say the SFPUC was probably the closest project to that we've studied in depth at this point in time. We're aware that there were a number of, I would call them mid-sized tunnels, less than 20 feet in diameter, that were bored by Sacramento Municipal Utility District as part of their wastewater system, probably 10 to 15 years ago. Those went very successfully in the Delta also. We're expecting that the ground is going to be relatively uniform. It's going to be layers of silt sands and clays, but over the 45-foot diameter of the tunnel boring machine, it's going to be a relatively homogeneous and uniform material that we're excavating. But yeah, tangentially, we've looked at those projects, but where we think they apply directly, but we've really been focusing on some of these larger projects as far as the sophistication of the equipment and the crews that are running these large machines.
And my last question is with respect to the staffing. You said that you would take a year to staff up, and then I assume when the contracts are awarded, those companies or awardees would also have an approach towards the jobs aspect of this. I'm sure you've thought about that quite a bit, as has the rest of the executive team. Can you talk a little bit about the jobs aspect of this and staffing and the approach for this project?
Yeah, there's really two aspects of that. Part of it is the hiring of consulting engineers to support the program, and then secondly, there would be the construction contracts themselves. In both aspects, the design and construction enterprise, while it's a separate department within DWR, we'll be operating within their small business environment, and I believe, don't hold me to this, I think they have a 30 to 35% participation rate by small businesses, so that would directly apply to the consulting contracts that are issued. And then we're also looking, because we do have I wouldn't say it's a concern, but an interest in us utilizing so much of the tunneling industry's capabilities within the Sacramento Delta area, that there is some discussion about setting up with the unions, some training programs for the craft and the labor that will be in the tunnels. So this is yet to be developed, but we are aware that those are subjects that we need to be keeping a close eye on.
Would you, because they're yet to be developed, and I understand the timing of this project is somewhat fluid, would you put that as a note in future presentations? I'm interested in that piece of it and would like to hear how you develop those, especially the training programs.
Okay, very good.
Thank you.
Take committee members first. Director Beard.
Thank you, Chair. I know in the past we have touched on spoils slightly. Is there any further update to spoils right now? What are we going to do with them?
Right now, as far as the EIR, EIS is concerned, the spoils will all be stockpiled near the work sites. We have cleared those areas environmentally on each of the islands and each of the work locations. So that is planned to be kind of the permanent resting location for the tunnel material. It doesn't mean that there couldn't be some future use of that material on completely separate projects, but that was not part of the EIR, EIS. Its final resting point is on the islands where the work takes place.
So the bulk of it would be conveyed after it comes out of the tunnel. It'd be conveyed, or are we looking at immense amounts of trucking?
No, we're looking at conveyor belt operations to move the material from the tunnel shafts out to the areas where it'll be dried and processed and then stockpiled.
Okay, thank you. Is there much difference between, you had traffic tunnels and water tunnels up there. Is there structurally much difference between the two?
There really is not when it comes down to the final finished product. I mean, both tunnels are concerned about leakage, I would say, into the tunnel. So if you have a transportation tunnel and you're going over under the Bosphorus Straits, you'd be very concerned with the integrity of the tunnel segmental system to keep water out. We are also concerned with that. The other added issue that we are interested in would be exfiltration or seepage out of the tunnel, because under certain operating conditions, our tunnels will be slightly pressurized, higher than the surrounding water levels. So we would have that potential for water getting out of the tunnel. So we have to factor that into our design of the segments also.
Okay, and then lastly, on the SR-99, did they not hit a casing?
Yes, I believe that's documented. The question, they did hit a casing, a steel well casing. The question, I guess, that's being discussed between the two parties is whether that was adequately shown on the drawings. And, we're not really in the middle of that.
Which you're reflected in your caution. So
yeah, I couldn't opine on that.
Okay, thank you.
Yeah.
Director Boyce.
Thank you, Chair. A couple of questions. I really appreciate the presentation, in particular the study of the other projects around the world. And you did a good job of analyzing the various risk levels of those projects. How would you compare that with a gut feel of the risk level of this specific project? Is this a slam dunk, or is this one really tough?
I think, I hate to say this like I'm straddling both sides, but I think it's somewhere in the middle. I think that there's areas that are going to be challenging. A lot of it has to do with the location of the project being in the Delta. We are identifying kind of the logistics to the site as being key challenges for the tunnel contractors. Getting material, equipment, and supplies into and out of these job sites every day, it's really going to become a logistical issue because there are only two major highways that go through the Delta, Highway 4 and Highway 12, and then we're relying on levee roads and anything else that we can construct along the way. We have the opportunity for barge landings. Those have been all cleared in the EIR, EIS, so the contractors will have the opportunity to bring materials in on barges. As far as the technology, I guess it's my personal opinion that, again, we're in the sweet spot of these large machines. I think the ground, while we have to do more investigations, the initial indications are that it will be somewhat abrasive, but it's going to be uniform in material, and we're not expecting to hit areas where it's just, oh gosh, we missed something, or we hit a big boulder. We're just not expecting that kind of ground.
Well, thank you for that. Also, I'm a little bit concerned about the fact that all of the projects that you've shown us, none of them were the traditional low bid type delivery project. They're all design bid build, P3s, what I'll call alternative delivery systems. With us being a part of the project team, assuming this is all approved and goes forward, do you anticipate educational opportunities, or do we need to work on our culture to adapt to a somewhat different bid process, delivery system process?
Well, I think this subject is something that the management team up in Sacramento definitely wants to bring up to executive management, leading the entire program, about the opportunities of alternative delivery for this program. There may be opportunities for it. Design, bid, build may be quite appropriate in some aspects of the project, but there may be opportunities for doing things a little bit differently on some of the contracts, and I think that's what we're kind of learning from some of our experiences, but it's still an open question. Right now, DWR and MWD can do design, bid, build. That's our delivery method, and that's our default at this point.
Okay. I would just add the design, bid, build is really considered fairly traditional. It's what MWD's done on its major projects. It's what San Francisco PUC did on their projects. So, but certainly the trend is towards alternative delivery mechanisms. Probably 80% of those or so were alternative, not design, bid, build, and if we could do that, we'd certainly avail ourselves of that, but at least right now there's some legal restrictions on that.
Good, thank you for that. Appreciate it.
Director McKinney?
Thank you, Chair. I'm intrigued with this, what you noted about the challenge of logistics and getting people in. Of course, we've taken the tours up there and ridden over the levee roads, and you can imagine how constricted it is. Is this project going to build roads that continue to be a benefit of the project after construction?
We're anticipating that we'll be making improvements to some of the levee roads, especially the areas that we directly traverse across. We've made that commitment in the EIR, EIS. We've made that commitment to the State Board in our testimony to them. We anticipate that many of the facilities will be temporary, though, certainly as you drop down off the levee roads and then start crossing the islands. These would be less permanent facilities, as will be the electrical infrastructure that we bring in. The anticipation is that it would be just brought in for construction. Now, that's not to say that there may be improvements to some of the local county, state road systems that are in the vicinity of our project that our contractors will be traveling across. We have to work through all of these issues with the local building officials, city engineers, county engineers, and things like that in order to get the permits to haul across their roads. So there could be some improvements to those kind of roads as part of this project.
Is there a way that we can coordinate early on in the conception of the design to see if building better roads should be an outcome of this?
And there will be. That'll be pretty standard once you start working and getting down to the local permits. very similar to DVL when we ended up building, we were going to build some access roads, and then we just ended up building that major road, right adjacent to it, Dominic Parkway. Once we made the decision to go ahead and we were going to build several segments and then just build the whole thing 4 lanes, work that out with the county. That'll be this process as you get to the local permit.
I think it's an interesting point when we talk to the public about the benefits of the project, if that ends up being a part of it. Thank you.
That was the case.
Director Wunderlich?
My question's been asked.
Okay. Director Pasquette?
On request, you may already be planning this, Chair, but this is such a helpful presentation by staff. Now that it feels like this project's going, it would be nice to have it as a permanent part of the committee agenda, if that works.
Well, we'll have it next month for sure, and then we'll see beyond that.
We'll
We're going to have
provide
kind of a
regular
tight schedule once the project gets near approval. And no other questions? All right, thank you. Thank you. Good job, John. Okay, Roger.
Yes, let me introduce Jacob Katz. We're very fortunate that he has made the trip down to our committee meeting today. Several of the directors, when you've been touring in Northern California, may have had an opportunity to go out in the Yola bypass. Some of you may have heard the presentation by Jacob. He's really the brains behind the Nagiri project. And the other efforts going on that shows fish and farms compatibility, and has done a lot of really good work in the bypass and elsewhere. So Jacob's with Cal Trout, who's an environmental organization that likes to get things done on the ground and has really done some cutting edge work. So Jacob, if you've heard Jacob talk, he knows a lot, and he can talk for a long time because he knows so much. Now, Bernarski does too, and so we're pushing the clock just a little bit here. But Jacob, again, thank you much for coming.
A great pleasure to be here.
Dr.
Thank you,
Katz.
Roger. I've already been told by Chairman Peterson that I'm on a short tether here, so I'll do my best to
The word was
stick to the game plan. But what I'd like to do is actually take a step back. Often in meetings such as this, we're required to do that 30,000-foot overlook. In understanding the function of the Central Valley, how the ecosystem actually works, and therefore managing it effectively, it's really helpful to get into get in on the ground, come in lower. And the amazing presentation we just saw, one about improving and updating infrastructure to assure reliability, is essentially the exact same presentation I'm giving here. But what we're talking about is ecology as technology, understanding what is now often recalled to as green infrastructure, understanding the landscape level processes that once made the Central Valley one of the great wildlife landscapes on Earth. 2 million, annually 2 million at least salmon swimming underneath the Golden Gate Bridge into the upper Sacramento and into the San Joaquin systems. Literally hundreds of millions of waterfowl. That incredible abundance has diminished year after year for well over a century and a half. And what I'm here to tell you today is that is not necessary. That loss of abundance, that the overwhelming sense of a broken ecosystem that we have is not inevitable. That it is a direct result of the infrastructure that we as Californians started to build 150 years ago when no one knew the word ecosystem, when no one was paying attention to fish, much less knew much about them. And that the actual footprint of our levees, our water diversion structures, placed in that era, in the industrial era, it is the direct result. That's why we have a system that has resulted in so many endangered species. But there are alternatives that are very cost effective, that are right at our fingertips, and that's what I'm here to talk about today. So let's talk about floodplains. Floodplains, of course, are where water meets land, where a river spreads out onto the low-lying grounds adjacent to the river channel itself. Floodplains are the river, and they can be managed for multiple really important benefits. First, in the Central Valley, our floodplains are the backbone of the flood protection infrastructure. The reason that Sacramento can be where it is because during large events like the ones we're in the middle of right now, the water flows up and out of the river in designed places where the levee invert is lower. So instead of flowing up over I Street and down 20 feet into the streets of Sacramento, it flows into the YOLO bypass. YOLO bypass then can actually cover about 450,000 cubic feet a second, which is 4 to 5 times the amount of water that passes down the Sacramento River channel, which is to say we have a functioning floodplain right now. It's the reason that people live in the Central Valley. It's the reason that the Central Valley can be one of the most productive and lucrative farming regions on Earth, right? Those flood bypasses are farmed. This is not just important because farming is the economic engine of the Central Valley, the vitality of our valley communities. It's because agriculture is also the vegetation management, cost-effective vegetation management method. If those bypasses weren't farmed, trees would grow, trees block water. Instead of water going into the bypasses, it would be flowing over the levees into our cities. Critically, of course, those floodplains, we now know after about 20 years of research, much of it through the University of California, Davis, Berkeley, but also with our partnership with the agencies, both state and federal, have shown that these floodplains are some of the best habitat. Habitat, of course, for ducks, for geese, for waterfowl and shorebirds, but now increasingly we understand that this is some of the most important habitat to sustain fish. And we're not just talking about salmon, although I'll talk about salmon quite a bit today. This is also Delta smelt, green sturgeon, the entire suite of freshwater fish found here in California. The other thing, of course, is aquifer recharge. You guys down here in Southern California are ahead of the curve in understanding that you have to slow down stormwaters and spread them out in order to infiltrate them back into our groundwater basins. We now know that that is wealth, that we're talking about taking that water, getting it back into our aquifer so that it can be used later. Again, this idea of storing winter's water for summer's use, but it's also absolutely critical. This function, the form of water spreading out and slowing down across the landscape is the absolute critical key of everything I'm going to talk about today. It's what facilitates groundwater recharge, but it's also what facilitates the incredible productivity of the floodplain that leads to ecosystem abundance. And that's what we're going to get into. So we can design these, water solutions that work for fish, for wildlife, and for people if we understand the natural processes that once governed the Central Valley and water flowing across California's landscape, right? So we're integrating this knowledge of nature, a 21st century ecological understanding of natural process into a water infrastructure largely built 100 to 150 years ago when little of that was understood, right? And so in order to do that, we have to understand the very system that we're talking about. For now, let's focus on the Sacramento Valley, right? These counties you've heard, Butte, Sutter, right? Colusa, Yolo. Those names come from the flood basins, from the low-lying ephemeral lakes that would happen every year as the Sacramento River and its tributaries came out of their banks during rain and snow events and flowed out onto the Central Valley, creating a mosaic of different wetlands that was roughly 4 million acres wide. In extent. That was not any specific kind of wetland, right? Wetland is just ground that is saturated, that is there for a long period of time. We're talking about willows, we're talking about ephemeral lakes, we're talking about emergent vegetation, a whole different suite of different wetland habitats, right? And all of that fed by this simple process of water spilling over natural levees and out onto the floodplain. Why am I focusing on this? Because if you don't understand the way that water actually flows across the landscape, you can't manage it effectively. You can't optimize the way in which we actually meet our environmental needs and the needs of people. So the key piece here, and I'm going to illustrate this with a LiDAR map. So this map is looking down basically just north of the city of Sacramento. We have the Sacramento International Airport here. This is the Feather River coming down, and this is the Sacramento, so the confluence of the Sacramento and the Feather Rivers. And the point of this is to drive home a very simple concept, and that's that the high ground is actually at the rivers. Rivers, as they spill out of the mountains, are full of energy. That energy is to hold sediment up. We talk about the capacity of a river to hold sediment. As the water slows down on the valley floor, it loses that energy, it drops that sediment. When a river spills out of its natural levee, it is losing energy and it drops that sediment. The red areas here show high ground, the green is low. What we're getting at is that the Natomas and Sacramento basins, low ground. The Yolo Basin itself, low ground. Sutter, low ground. And that was taken advantage of when the water infrastructure was designed. So the Yolo Basin and the Sutter Basin were taken as these pressure relief valves where we wouldn't develop, we would farm, but we would pass the floodwaters through those areas, right? So there was this idea of every water year wasn't the same, right? In some years you would have an inland sea. The first storm, of course, 1862, right? When it rained literally for 40 days and 40 nights from Christmas of 61 through January of 62, right? You had 3 feet of fresh water on San Francisco Bay itself. They were catching freshwater fish on Fisherman's Wharf, right? Leland Stanford, when he went into his inauguration in 62, took a rowboat here down K Street to the Capitol, which you'll remember is built on a hill, right? On a levee, in fact, on a natural levee. So this idea of an inland sea, of course, in big water years like this one, we would have had large, but it was not every year. What you had was a shifting mosaic. In dry years, you still had a whole bunch of wetland, but it would have been of different kinds, right? Of course, that all changed. Within 100 years, starting in the mid-1800s through the early 1900s into the 20th century, reclamation was the name of the game, right? A very simple concept, drainage, right? 13,000 miles of levees were done. The impact of this is hard to overestimate, right? A system, and if you think of the valley as a bathtub, right? It had a fairly narrow outlet right there past Rio Vista going into Sassoon Marsh. Huge rains. We all now know what a Pineapple Express is, what a rain on snow event is. The valley can get an immense amount of water, and when it does, the bathtub fills up. Those wetlands inundate for various long amounts of time, but the key is for quite long periods. And what did we do? We drained it, right? Every single acre of farmland is designed just like a Safeway parking lot to drain that water off as quickly as possible. Right? That is the hydrological antithesis of the natural function of the ecosystem. Right? We understand now, again, from groundwater recharge, the incredible wealth we were squandering by sending that water out to sea. Right? But it also was the basis for how the native critters interacted with the California's landscape. When you fundamentally change that, hence, when water no longer flows out to sea but flows up towards pumps, you confuse some critters, right? We've been in there. That much of this is taken into account into California Water Fix. It's not just at Water Fix. It's throughout the entire system. So if we look to California's native fishes, this is work that I did for my dissertation at UC Davis with Peter Moyle. The first time you'd looked at all 130 different kinds of fishes throughout the state of California. You put them through a standardized way of looking at conservation status. And you found something that even surprised Peter and I, the doom and gloom environmentalists that we are. 83%, well over 3/4 of the fish in the state are headed towards extinction. Right? What's remarkable is not that we have endangered species, that Delta smelt or winter run salmon or green sturgeon dominate the headlines. What's remarkable is that we've lost so few, because it's not just in the Delta or the Klamath or the Russian River or the water withdrawals in the spring systems down in Death Valley. Everywhere across California, we are the hydraulic society. We have fundamentally changed the way that water flows across the landscape. We've done it in a way without considering the environment, and this is the legacy of that. Now, when I look at that, you can take a standard doom and gloom, this is the way, but I look and I say, well, we actually haven't been creating our solutions. We haven't been imagining our solutions at the actual scale of the problem. We've been addressing symptoms and not root causes. And so if we can fundamentally start to understand what's actually driving extinction and decline, then we can start to reverse it. And maybe a great way to look at that is just start in the Central Valley and just look at Chinook salmon. There were 4 runs of Chinook salmon, right? 3 of them are now endangered. The one that is not is almost entirely maintained by a hatchery system, which has many faults its own. What I want to do is look at how did the system work prior to altering it, so we can start to understand what we can do within this intensely managed landscape to mimic those natural processes, to allow native fish and wildlife to recognize the system that they evolved in and to flourish. Is that possible? Yes, I believe it is. So the Cosumnes River, many of you may not be familiar with it. It's so small it didn't even get a dam. But what that means is that when it rains on the Cosumnes, the water comes up. And when the water comes up, there are several places, old tomato fields where a levee failed and the farmer didn't bother to fix it, that function very similarly to a pristine floodplain, meaning that the water spills out over a levee and sits out on the land, right? And about 20 years ago, Dr. Moyle at UC Davis and others, his student Carson Jeffries, my colleague in all this work, did a small experiment. They said, well, you know, most people think that that's a swamp, right? And we know that fish they belong in the river, right? A river belongs in its bank and the fish belong in the river. What's happening out there on the floodplain? Yeah, maybe that's important for ducks, but surely, you know, salmon don't belong out there. And Peter and Carson said, well, let's find out. Let's look. And they did a very simple experiment, placing caged fish on one side in the river channel and on the other side in this inundated floodplain, like you can see there on the right. And the results of that are now familiar to all. This picture shows the floodplain fish on the right and the ones in the river on the left. The river fish barely grew at all. Those on the floodplain were growing at immense rates. What I now know and what I can tell you is this is the first glimpse in the modern era of what a Sacramento salmon should look like. There's real truth in some of our, adages and phrases. You don't want to be the smallest fish in a big pond. This guy has a lot of gas in the tank, right? This guy not so much. This guy can swim. He can this one can outswim a striper. Not so much. This size of fish has a much better chance of returning. And that's not backed up just from data in California. If you look to every kind of seagoing trout and salmon worldwide, you will see evidence that suggests that size at ocean entry, when a juvenile salmon or trout is hitting the ocean, is the best indicator of when, if that fish returns. So this was groundbreaking, but it was the first glimpse. And it was an important glimpse, right? We had a little postage stamp, 15 acres of functioning floodplain, right? There used to be 4 million acres. We're looking at a map here of the Sacramento Valley. This would be the Sutter Buttes right in the middle of the city of Sacramento down here. And again, all those different colors are just to show the different kinds of wetland habitats, right? And this would have been pre-development. Today, 95% of those are gone, right? So we had 15 acres of pristine habitat. It looks like fish do really well there. One reaction to that can be, so what? I mean, I was just talking about trying to scale the solution at the same scale of the problem. Landscape scales, trying to bring back abundance. That's going to fundamentally need to be tens of thousands, hundreds of thousands of acres. A little expensive restoration project here and there isn't going to do it. $400 million in public funds to bring on 125 acres just fundamentally isn't actually a solution at all. But where did all that floodplain go? If you overlay a map of agricultural production in the Sacramento Valley on top of this, you get that. Any guesses what that green is? Rice. The rice ground is that low-lying swamp area. It's the deep clays. That's not suitable for orchards. That's not going to be nut ground. It's too heavy for rotational crops for tomatoes, but it is some of the most productive rice ground on earth, up to 9,000 pounds of rice per acre. That is the heart of Sacramento Valley agriculture. And we had a question, understanding that we're never going back, understanding that that lucrative ground is never again going to be at least at the scale that we need it to be. Tens of thousands to hundreds of thousands of acres, waving, fields of tule. But can we, within this managed system, mimic those natural patterns? On a rice field that still grows food for people in summer, in winter, can we make the food? Can we mimic the natural flood patterns, spreading water out and slowing it down, that allow incredible food and habitat to be produced? And after 5 years of doing this in YOLO Bypass on Nags Ranch, I can tell you unequivocally, yes, absolutely. Now, I can't get into the details, which is, I'm a science geek. I'd love to talk to you about all the details of 5 different years of experiments. But basically, we said, hey, if you're a rice grower, what can you do to make it better for fish? And we looked at depth. We looked at how you cut your rice stubble after harvest. We looked at substrates, a whole bunch of different farm practices. And after 5 years, I can tell you, after looking at all these different things, if you can get that water spread out, if you can slow it down, you make an incredible amount of bugs. Those bugs make fish. They're very happy. They're very big. They look like this. This top fish was put in on the first year of our experiments in 2012, the end of January. It doubled its weight every week, looking like this after 6 weeks. And then when captured, leaving YOLO Bypass, entering the Delta, it looked like that. So that's not just a fat fish. We call them affectionately floodplain fatties. What we're actually talking about is the capacity of the Central Valley to actually produce biomass. You're talking about the driver of natural productivity that we have, in essence, surgically removed by straight-jacketing our river channels. Now, what do I mean? First, let's just look at, some fat fish from each year. Again, these are some of the fastest growth rates ever recorded in California. It's not simply that it's something abnormal happening at Nags Ranch or on the roughly dozen other floodplains from the San Joaquin well up into the Sacramento Valley where we've done these experiments. This is what a Sacramento or Central Valley salmon should look like. In essence, we are starving our salmon populations and the rest of our fish populations currently, again, as a direct result of a water infrastructure put in place well over a century ago. And they look like this now. Similar results. Maybe this is the best way to just give you a glimpse into some of the experiments we do without getting into the details too much. Last year, I did what I call an aquatic transect. So we just, at the Sacramento River, just north of the city of Sacramento, at Nags Ranch, this is the Sacramento itself. This was the first time in the 5-year study history that we actually had flooding and it was coming into YOLO Bypass. So we took some small floating cages, put 10 fish into each one of those cages. The tagging technology is such now that a tag the size of a grain of rice, I can inject that into the body cavity of a fish and I can follow each one of those fish. I know their names. I can track, that's Harry, that's Sally, this is Jack, and you grew this much under this period. That means that our science, the statistical validity of what we've been putting out here has not been matched prior. So here's fish growing in the Sacramento River. Here's the Tule Canal just on the other side of the levee. Again, the levee is just there to the left of this picture, right? So you're talking about 30 yards on the other side. The canal system is how water tends to move across the floodplain as we manage it today. And then we have what I call managed agricultural floodplains. Rice fields that were reflooding in winter to mimic the way that water would have slowed down and spread out on a natural floodplain. Those fields also get the same exact treatment of cages and fish. And what do we get? Well, we had a flood. We only could do this for 3 weeks last week, but this is the results, right? Again, more fat fish. Those in the river barely grew. Those in the canal grew, they're starting to get a little belly, a little pooch, but the floodplain fish are dramatically larger. And this was the first year that we really can pin down why. Sac River water. This is the bugs that come out of a cubic meter of water, right? There was about 1,500 bugs per cubic meter of water. That seems like that would be a lot. Well, there was about 6 times more in the canal. That is zooplankton. I call this zoop soup, all right? There's 150 times as much to eat in that, in there. Just the other side of the floodplain, right? 100. So here, let's bring this back into job forecasts, in fact, right? So if you're off by 7% on your OL, that was okay, right? The big dig's off by 3 or 4 times. Oh, okay, right? Say you increased profits by 10% as a CEO, you can probably expect a bonus. You doubled profits, right? This is 150x. That's 15,000 times more food available 30 yards on the other side. We have designed an entire system that deprives these animals from their food source. I can explain why that food source is so much larger now. I will in a minute. But this is ludicrous, right? I shouldn't be here telling you that fish need to eat. But I am. That's, if you leave with just a single idea, fish need to eat, right? Our levees are starving them. How do we fix that? We can put those solutions together really quick. They're quite economical, right? We've already been working with Roger's team in the Sacramento Valley to start to put these water infrastructure upgrades into effect that take into consideration the life history of fish. But for very little investment, we can actually expect revolutionary outcomes. And there's very rarely that you actually get a chance to do that. So here's just, throwing that onto a slide, right? After only 3 weeks, the red line on top is the river growth, the canal growth, and the river. 700% greater growth in just 3 weeks. That expands each week. By in years past, we've seen as much as an order of magnitude greater in as little as a month. So really substantial. And this is what it comes down to, that it's really as much about physics as it is biology, right? The solar panel of the floodplain is what powered the aquatic food web. What do I mean? Well, what's food for people? It's just when sunlight gets turned into sugar by an agricultural crop, right? And we've been measuring productivity of the Sacramento Valley's floodplain in 100-pound bags of rice for well over a century now. What we're saying is you can still do that. You can still have your productivity in summer, but in productivity in winter, we can now start measuring those environmental benefits. Those include water recharge, right, which is easy to put dollars on, but they also includes fundamentally changing the productive capacity of the valley to produce fish. And actually, in the ultimate economic analysis, that may be the biggest change. It's a difficult one, it's indirect costs, but we all understand that dysfunction within our environmental management is one of the greatest challenges to water security. And more fish ultimately equals greater water security, and that's exactly what we're talking about here, right? So mimicking hydraulic processes, right? Understanding how water used to flow across the landscape and mimicking that in a very intensely managed system. We're not talking about restoring pristine habitats. We're talking about restoring ecological function. We're talking about actually starting to address the drivers of the system instead of the symptoms, right? And again, I'm just going to do this one more time. Sunlight. All the energy comes from the sun, right? Sunlight turned into sugar by vegetation during summer, right? All of those plants turn that sugar. Sugar is the fuel of the entire system, right? In summer, vegetation growing on the floodplain. In winter, that's algae floating near the water surface. Either way, you're making sugar. Sugar makes bugs, bugs make fish. A very simple floodplain food web, but one that has immense economic consequences, not just here in California, but globally. Because this is true not just of the Sacramento Valley, but every large river valley in the developed world. It's the Seine, it's the Thames, it's the Danube, right? We have straitjacketed our systems. We are experiencing the same kind of environmental degradation and collapse in those places, and it has the same environmental economic consequences. A very simple way of looking at that. We're running out of power. Your car doesn't work when you don't put gas in it. My kids' toys don't work when I pull the batteries out, right? I need to eat. All of that has to do with the exact same thing that we're talking about now. We need to put the batteries back in the system. What does that mean? It means reconnecting our floodplains to our river in specifically designed places where we can, on an annual basis, do so. YOLO has been the target, but there are many other places where we can do that and many different methods in which we can achieve it. Remember the take-home? Well, here's the picture that should be ingrained. You know, when you go to sleep tonight, that should be on the side of This is the back of your eyelids. Now, this is not a cherry-picked fish from the river and a cherry-picked one from the floodplain. We actually had to go in the river because we were tagging this fish. This was the biggest fish we could find coming out of the Feather River. All right? Now, I think most people think, oh, because there aren't fish coming back, that they assume that the Central Valley doesn't produce small fish. And that's just blatantly not true. A look at the data, say, from 1998 will show that roughly 100 million small fish were produced in the Sacramento Valley alone, right? Those fish are about the size of your thumbnail, right? They don't have anything to eat. They can't find anything to eat. And unless there's large winter storms that flush them, literally flush them out of a hostile system, out to the California current, into the Fairlawns, where the wind's blowing and the upwelling's going and the eating's good, we don't see these guys again, right? But if you just allow them to make it into some kind of habitat which approximates the way the valley used to look like, within a matter of weeks they look like this. And you're changing the outcome of the fish life histories within the system. So, excuse me, wrong thing. Again, I just want to talk back, just reiterate, slow it down, spread it out, right? That's the only way that you're going to grow it up. This is a kind of a wonky way of showing that. I'll get into it. But it just says, this is the floodplain, right? This is time. First it gets wet, then you start to get chlorophyll and bacteria, then you start to grow bugs. It takes at least 10 days, if not longer, to start having the food out on the floodplain. It's not just about getting it wet, it's about keeping it wet. And that is so absolutely fundamental to the way that we need to manage this system that I felt we needed to do it. And maybe the easiest way to analyze that into analogy is a bathtub, right? So if you're just thinking about flow and not talking about holding that water back out there, well, you can always fill a bathtub with a fire hose, right? As long as more water is going in that's coming out. It's costly as far as the amount of water used, but it'll fill that bathtub up. Now I'm thinking about YOLO bypass, a 60,000 acre bathtub, right? It takes a lot of water to fill it up. If we allow it to continue to be drained the way it is now, specifically designed to pass that water as efficiently as possible, that you can fill it up and 5 days later, it's no longer inundated. You're not getting the benefit you need for those fish. If you use the plug, you get so much more benefit for so much little investment. And what that means from an infrastructure perspective is starting to, yes, we need to allow water through our levees onto our floodplains, but then once the water is out there, we need to manage it. Again, very shallow. This is essentially what rice fields do anyway. They're surrogate wetlands. The water isn't allowed to leave a rice field because you drop a 2x4 in front of a culvert to block its movement, right? We can design infrastructure like that to create managed wetlands of 1,000, 3,000, 5,000 acres. Very little investment. Projects that cost from 5 to 15 million, but that fundamentally change the productive capacity of the bypass and of the system. So there's a relatively disgusting picture of what this means. Those are the small bugs, the cladocer and the water fleas, which are like floating filet mignon if you're a trout, right? They're swimming around, my guys, with their eyes closed and their mouth open, sucking those up. And all you need to do to be able to create that, to inject that back into the system, is to start to allow our water to spread out, to slow down, and then to reconnect with the valley. So I just want to make sure that you understand that this isn't just Cal Trout, that we're working as incredibly closely with all of our state and federal partners, and that really increasingly the close work that we have, not just with Met and water contractors from Southern California, but with the large ag and water interests in the Sacramento Valley, is what's turning the tide, is what's that close collaboration, bringing fishermen and environmentalists, farmers and water contractors together to say, yeah, there's a lot of arguments out there. You know, pre-1914 rights versus the ESA. That has to be resolved. But in the meantime, there are projects that we all know help everybody and that we can get built. And that record of going out there and in real time on the ground, building things, getting it done, showing that success can build success and that we can do it together is why I'm here today. Is several projects that we've done in partnership with Met and others have, I think, given us a momentum that we have to start to scale up, to actually start to create infrastructure solutions. Again, this is ecology as technology. We're talking about using our floodplains effectively, optimizing their use for the environment. That I think can fundamentally change our endangered species problems. So with that, thank you very much.
Thank you,
entertain
Dr.
any
Katz.
questions.
Unfortunately, we are out of time, so there won't be a lot for questions, but go ahead.
That's the short tether.
There'll be other opportunities for questions, and there's always opportunities to go look at what's going on here. And I just think that this is a good time for me to make a comment about what's going on kind of nationwide today. And you may be hearing people pushing back on what may be happening in Washington. And for us, I don't see anything changing. We've been down this road for a long time. We're not going to stop. We're not going to change. To me, what's going on here is, for Metropolitan, we haven't just all of a sudden started working with agriculture. We've been doing that for a long time. But this is an indication or representation of how we're sort of closing the loop on metropolitan agriculture and the environment. And this is really exciting. Thanks for being here, Jacob. And we're going to continue, obviously, working with you and all these other partners here. But it's very exciting. It's just, we're not changing our commitment to what we believe in as stewards of the environment. So I think this is a good example of that. Thank you.
So if anyone has questions of Dr. Katz, he'll probably join us for lunch.
I would love to, and
yeah,
sorry to be long-winded. I was looking forward to the discussion, and thank you very much for having me.
Right. So any future agenda items? Roger, do you have a report?
Are we going to have Hal? We're going to skip that, right?
Skip it?
Are we going to skip Hal? Do you want Hal to do his?
I think, can we do that next month?
Yeah, let's hold that over. I just had one thing. This is exciting stuff. We'll have some follow-up. We're partnering in an experiment this year to bring a lot of private landowners into this food production thing, which I think is really going to be pretty cool. I just wanted to give you a bit of a snapshot on water operations. Dimitri will go into details in 2 weeks. But this is some pretty unusual circumstances up north as well as down here. Since last Wednesday, we have been pumping at near capacity. We haven't seen this forever, and it's pretty unique. But that means Central Valley Project can pump 4,100. That's what they're pumping. We are pumping 10,300. So that means we're pumping 14,400 roughly between the two pumping systems. And we're meeting the biological opinion at the same time. That's pretty tricky. But what's happened is it's been wet, obviously, and we have flood releases at Folsom, Oroville, and Shasta. So they're cutting back a little bit now. We're kind of between storms, but they were releasing about 100,000 CFS combined on top of the other runoff. That about 2/3 of it was going into the bypass. But what's really allowed us to pump is the San Joaquin system is pretty much full, and normally we'd be 1,000 to 2,000 CFS. We're at 18 now. And so that means essentially that's water we can pump without eroding the Old and Middle River requirements. And so we've been pumping at maximum capacity primarily because of the San Joaquin, and I think it's going to run. It's going to run for a while. I mean, a while being 2, 3, who knows, weeks, month. So as a result, we're within about 100,000 acre feet of filling our share of San Luis. We're adding about 10,000 a day. So we're getting there, and we've done all of this, and we've taken one Delta smelt, and that was about 2 weeks ago. So it's worked. Surprisingly well, and we anticipate that it'll continue to run. I always track how much extra water could have we gotten if Cal Water Fix was in place, and the answer is not very much because we're pretty well maxed out now. The official number from that I got from the state and the state contractors was like 147,000 acre feet, but we're pretty well maxed out now just because of this unusual circumstance with the San Joaquin. So, like I say, we'll get into that in more detail, I'm sure, at water planning, and we may be basically full at San Luis, I think, by then. So.
Any questions of Roger? Okay, seeing none. There's no future agenda items anyone wants, so we stand adjourned.